In this video, I'm going to show you how to apply mathematical operation between images. And so I'm going to open the same image than before. We will use the same image for the entire session. So the nuclear image. And I'm going to apply a Gaussian blurring to this image. And then I will try to evaluate the effect of this blurring by subtracting the blurred image to the original image. So let's first apply Gaussian blur. So process, filters, and then Gaussian blur with a sigma of, let's put it at 3, so it's going to be more important blurring. All right. Now I'm going to open the image again, and I'm going to subtract the blurred image to the original image. So it's fairly easy to do that. You go to Process, Image Calculator, and then you see you can do several operations: add, subtract, multiply, divide, and then that's N or X or min max, average, difference. Alright, we want to subtract the blurred image, so I'm going to select subtract. And here I'm going to put, so this is the image I opened again, and this is the one that was blurred. So you need to make sure that they have the same type. So here both are 16 bits, so that's fine. And I would say it's always better to tick this box, so your result is in 32-bit. So especially, if you do a subtract, you're gonna most probably have negative values, and if you don't have this box ticked, then you won't be able to visualize the negative values. It will be equal to 0 again. So let's do it. And this is the result, so we can adjust the intensity a little bit if we really want to visualize what happened. So as you can see in the background, if I zoom in, you don't have much difference because the background is pretty uniform. So when you blur it, you're gonna have a value that is similar, and you won't have much difference. It's gonna be sometimes a little bit higher, sometimes a little bit lower, so you have positive and negative values, but close to 0. Now, inside the nucleus, inside the nuclei, the intensity is less uniform. So if you blur it and you remove the average, then you're gonna have low values in the minimal, in the local maxima. So if I look at the original image, I'm just gonna adjust the intensity again, and if I'm gonna try to zoom in the same region, so you're gonna have, when you blur it, it's gonna be something that is average. So where you have local maxima like this, it's a bit higher intensity than the pixels that are around. When you blur everything, it's going to be a lower value, so then your local maximum going to appear even more. And when you have lower intensity, same thing. Okay. And finally, which is probably the most striking, is in the contours, because in this you are in region where you have high intensity on some part, and in the other part it's going to be low intensity. So when you average, it's in between. So when you're on the contour, you're going to have a high difference, and that's why you have negative values just on the contour. Here it's even more striking when you have very huge differences of intensity between the nucleus and the background.